When it comes to home insurance, Geico works for you. And since I'm the Geico Gecko, I'm here working for you too.
Hey, Gecko, can you record my voicemail greeting?
No problemo. You've reached the amazing Rita. She's probably busy right now teaching music theory to neighbourhood birds, or telling a total stranger how they can bundle home and car insurance with Geico to get the discounts they deserve. But rest assured, she'll get back to you once she's done brightening her little corner of the world. Did that sound all right?
Nailed it. No notes.
Let Geico work for you. Get more with Geico.
This is SpaceTime, Series 28, Episode 99, for broadcast on the 18th of August, 2025. Coming up on SpaceTime, the most massive black hole ever discovered, the detection of what looks like another planet in the Alpha Centauri star system, and the growing concern among scientists about the ongoing proliferation of satellites in Earth orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered what's potentially the biggest supermassive black hole ever seen, called the Cosmic Horseshoe because it's so big it's distorting space-time. This behemoth's estimated to be around 36 billion times the mass of the Sun, and that puts it close to the theoretical upper limit of what's possible. Located some 5 billion light-years away, supermassive black hole warps and gravitationally lenses light from background galaxies, turning its appearance into that of a giant horseshoe-shaped Einstein ring. A report in the monthly notices of the Royal Astronomical Society claims the monster's located in one of the most massive galaxies ever observed. Astronomers believe that most, if not all, galaxies contain supermassive black holes at their centres, and the bigger the galaxy, the bigger the black hole. One of the study's authors, Thomas Collette from the University of Portsmouth, says the Cosmic Horseshoe is among the 10 most massive black holes ever discovered, and quite possibly the biggest of all. The thing is, most of the other black hole mass measurements have been through indirect methods, and that means there's quite a bit of leeway for uncertainties. So astronomers don't really know for sure which is the biggest. However, Collette says they've got far more certainty with the mass of this black hole thanks to the way it was measured. The authors detected the Cosmic Horseshoe black hole using a combination of gravitational lensing and stellar kinematics. Gravitational lensing involves the bending of light from background objects by the mass of a foreground object. And kinematics is the study of the motion of stars within galaxies and the speed and way they're moving around black holes. And the latter is seen as the gold standard for measuring black hole masses. But it doesn't really work outside the very nearby universe because galaxies appear too small in the sky to resolve the region where a supermassive black hole lies. But adding gravitational lensing allowed the authors to push much further out into the universe. So they were able to detect the effect of the black hole in two ways. Firstly, by the way it's altering the path that light takes as it travels past the black hole, and secondly, the way it's causing stars in the inner regions of its host galaxy to move extremely quickly around the black hole, often at speeds of greater than 400 kilometers per second. By combining these two measurements, astronomers could be completely confident that the black hole is real. This discovery was made for what's referred to as a dormant black hole. That's one that isn't actively accreting material at the time of its observation. So its detection relied purely on its immense gravitational pull and the effect it has on its surroundings. Now, typically, for such a remote system, black hole mass measurements are only possible when the black hole's active. The authors are describing the Cosmic Horseshoe system as a fossil group galaxy. Fossil groups are the end state of the most massive gravitationally bound structures in the universe, arising when they've collapsed down to a single extremely massive galaxy with no bright companions. Collette says it's now likely that all of the supermassive black holes that were originally in the companion galaxies have now been merged to form this one single giant. So that means what we're really seeing here is the end state of galaxy formation and the end state of black hole formation. This is SpaceTime. Still to come, astronomers discover what could be another planet orbiting in the Alpha Centauri triple star system. And there's growing concern among scientists about the ongoing proliferation of satellites in Earth orbit. All that and more still to come on SpaceTime. astronomers may have discovered another planet orbiting the Alpha Centauri triple star system. At a distance of just 4.25 light-years, Alpha Centauri is the nearest star system to our own solar system. The system's located in the southern skies. It's the second of the two pointer stars showing the way to the Southern Cross. The system comprises two sun-like stars, Alpha Centauri A and B, which orbit each other. Alpha Centauri A is fractionally larger than our Sun, Alpha Centauri B just a little bit smaller. And both are orbited by the system's third star, the red dwarf Proxima Centauri, which right now is the nearest star to the Sun, consequently the second nearest star to Earth after the Sun. Astronomers have already confirmed 3 planets orbiting Proxima Centauri, but the search for possible worlds orbiting Alpha Centauri A and B has proven to be far more challenging. Now, a report in the astrophysical journal Letters has used observations from NASA's Webb Space Telescope's mid-infrared instrument to suggest that a Saturn-sized gas giant is orbiting Alpha Centauri A. Alpha Centauri A is the third brightest star system in the night sky. Now, if confirmed, it would make this planet the closest to Earth orbiting the habitable zone of a Sun-like star. The study's lead author Charles Beckman from NASA's Jet Propulsion Laboratory in Pasadena, California, says that because this exoplanetary candidate's a gas giant, it's not likely to support life as we know it. But Beckman says with the system being so close, any exoplanets found there would offer a great opportunity to collect data on planetary systems other than our own. Yet these are incredibly challenging observations to make, even with the world's most powerful space telescopes. That's because they're orbiting stars that are really bright and close and moving quickly across the sky. Webb was actually designed and optimized to find the most distant stars and galaxies in the universe. So the operations team at the Space Telescope Science Institute in Baltimore, Maryland, had to come up with a custom-designed observation sequence just for this target. And it looks like this extra effort may well have paid off spectacularly. Several rounds of meticulously planned observations by Webb, careful analysis by astronomers, and extensive computer modelling all combine to help determine that the source in the Webb image is likely to be a planet and not just a background object like a distant galaxy or a foreground object like a passing asteroid, or for that matter, some sort of detector or image artifact. The first observations of this planetary candidate actually took place back in August 2024, using the chronographic mask to block Alpha Centauri A's light. Still, the extra brightness from the nearby companion star Alpha Centauri B complicated the analysis. Nevertheless, Beckman and colleagues were able to subtract out the light from both the stars, Alpha Centauri A and B, to reveal an object over 10,000 times fainter than Alpha Centauri A, separated from the star by about 2 times the distance between the Sun and the Earth, about 300 million kilometres. While the initial detection was exciting, the authors still needed more data in order to come to a firm conclusion. The trouble is, the additional observations of the system by Webb in February and April this year didn't reveal any objects like the one initially identified back in August last year. So to work out what was likely happening, the authors turned to computer models to simulate millions of potential orbits. And these simulations included both the new Webb data and also an earlier 2019 potential exoplanetary candidate sighting by the European Southern Observatory's Very Large Telescope in Chile. And they also considered orbits that would be gravitationally stable in the presence of Alpha Centauri B, meaning the planet wouldn't be getting flung out of the system. The authors say a non-detection in the second and third round of observations using Webb wasn't surprising. The models showed that the planet simply would have moved too close to the star to be visible during both the February and April observations. Now, if confirmed, the potential planet could mark a new milestone for exoplanetary imaging efforts. In fact, of all the directly imaged planets seen so far, this would be the closest to its star. It's also the most similar in terms of temperature and age to the gas giants in our own solar system, and the nearest to Earth. But its very existence in a system of 2 closely separated stars challenges our understanding of how planets form, and how they could survive and evolve in such a chaotic environment. Now, if confirmed by additional observations, the results could transform the future of exoplanetary science. Beckman says it would become a touchstone object. For example, NASA's Nancy Grace Roman Space Telescope, which is set to launch in May 2027, is equipped with dedicated hardware that's specifically designed to test new technologies to observe binary systems like Alpha Centauri in the search for other worlds. This is SpaceTime. Still to come, growing concern among astronomers about the worsening proliferation of satellites in Earth orbit. And later in the science report, early-stage trials have shown positive results for a vaccine specifically designed to recognise and kill cancer cells. All that and more still to come on SpaceTime. Astronomers have again raised concerns about the interference broadband internet satellites are causing to vital scientific research. The latest warnings have focused on radio emissions being generated by Starlink and other broadband satellites, which are interfering with radio astronomy observations. A study led by Dylan Gregg from the Curtin University node of the International Centre for Radio Astronomy Research specifically looked at the effect of the Starlink mega constellation, which now has more than 7,000 satellites in orbit. Grigg says Starlink is the most immediate and frequent source of potential interference for radio astronomy. It launched some 477 satellites alone during the study's 4-month data collection period. The problem is unintended signals coming from the satellites. The signals are being leaked by onboard electronics, and they drown out the faint radio waves astronomers are trying to study from the universe. Grigg and colleagues collected and analysed some 76 million images of the sky using a prototype of the Square Kilometre Array, which when complete will be the world's largest and most sensitive radio telescope. They detected more than 112,000 radio emissions coming from 1,806 Starlink satellites. That makes it the most comprehensive catalogue of satellite radio emissions at low frequencies ever undertaken. They found the Starlink satellites are causing significant radio pollution by interfering with radio astronomy observations, potentially impacting important discoveries and research. The study, reported in the journal Astronomy and Astrophysics, found that some data sets had up to 30% of images showing interference from a Starlink satellite. Now, these latest warnings follow ongoing similar concerns raised by optical astronomers who have had to deal with trains of Starlink satellites blocking out their observations of the night skies. Grigg says the issue isn't just the number of satellites up there, but the strength of their radio signals and the frequencies they were visible at. Some of the satellites were being detected emitting in radio bands where no signals are supposed to be present at all. And that included some 703 satellites identified at 150.8 MHz, which is meant to be a protected frequency for radio astronomy. Grigg says because they come from components on the satellites like electronics, they're not part of any intentional signal, and astronomers can't easily predict them or filter them out.
We wanted to find out what the prevalence of satellites were at the frequencies that the SKA low is going to be looking over, because similar studies with other telescopes around the world had seen satellite in images and data created of the sky. So, we designed a survey using a telescope called the Engineering Development Array 2. It's pretty much the same size as a SKA low station. And so we found a lot of satellites in the images that we created, most of them being Starlink satellites. And so the way we looked at the sky was we took images of the sky in radio every 2 seconds for about a month. And so that's how we searched for the satellites.
Something like 30% of the images showed interference from Starlink satellites.
In some of the frequencies that we looked at, we saw a lot of Starlink satellites in the images. And it kind of makes sense because if we see one or two of them, most of them are designed pretty similarly. And the launch of Starlink satellites has been almost exponential. So, it kind of makes sense that we'd see so many of them in the images.
Can you filter them out of the data to save the research, or is this just an interference we now have to deal with?
They're quite bright, so they're roughly sometimes the same brightness as like the brightest radio galaxy that we see in the sky. And when they're so bright compared to really faint signals from the early universe, which is what radio astronomers are looking for, it makes them quite difficult to filter out. But a lot of the time, the current mitigation strategy is just to get rid of data when they're visible, or be smarter in how the surveys are required so that you're looking at the sky with the telescope when the satellites aren't directly overhead.
Well, that's one of the big problems, isn't it? Because they're everywhere now. You've got potentially 35,000 of them. This is just Starlink alone. Potentially 35,000 of them about to be launched. Already you've got, over 7,600 at the time of recording this program?
Correct, yeah. So, there's going to be a lot more launch. So we've had dialogue with SpaceX, which is the company that operates these satellites. So we're hoping that, further discussion with them will help with introducing mitigations for future satellites that they launch because, there's going to be a lot more in the future.
And this isn't a problem which is new because when Starlink first began launching, optical astronomers began seeing them in their images and they began seeing entire trains of these satellites and more of them. And it's affecting research for optical astronomy to a huge degree. And even then, this is 5 years ago, there are already warnings that the same thing would happen in radio astronomy. And that's exactly what we're seeing.
Yeah, so in optical, SpaceX has made some good mitigations for the satellites. Like they made some changes like painting the satellites.
Black, and they're stealth satellites, they're calling them, but they're making some changes, but they're still coming up in images.
Oh, for sure, yeah. But at least there has been some progress towards mitigating it, and we're hoping that some similar mitigations could be made for the radio data as well. But with the sheer volume of satellites up there, and especially in optical, it's reflection of sunlight, so it's a little bit of a different transmission problem. But with the sheer volume of them being up there, you're going to see a lot of them.
I know we've been singling out Starlink for this, but of course it's not just Starlink. We've got Globestar up there as well. They've got thousands of satellites either in space or on their way there. Iridium is still there, and they've been around for years now. And you've also got Kuiper systems, Inmarsat. There are so many of them up there, and the problem's not going to go away. This is something, unfortunately, we're going to have to live with.
Yes, the number of satellites being launched into space is going to keep increasing, at least for the near future. So it's pretty important that continuing surveys are done to see if the prevalence of satellites in the images in all types of astronomy gets worse. And if it does, it's probably going to come down to having conversations with the individual operators and hoping, the emission from the Starlink satellites that we detected was outside of their designated downlink frequency. And so it's emission coming from somewhere on board the satellite's electronics. And so it's kind of a grey area of regulation at the moment. So there's no one regulating that. So we're, having continued conversations about getting this kind of stuff regulated in the future, which would help astronomy.
It's only by government mandated regulations that these things tend to change. Otherwise, companies who are out there to make a profit, well, they're going to drag their feet.
There's an organisation called the International Telecommunications Union, and so they regulate a lot of the radio emissions for these satellites, for the intentional transmissions, and they do most of the radio spectrum for terrestrial transmission on Earth as well. So it would be an organisation like that which would probably be in the best position to regulate something like this, and ultimately they're having those discussions to hopefully regulate it in the future. So it'll probably come down to an organisation that represents a lot of different countries rather than one country's federal government. That's the side of regulation of policy and stuff which my work didn't focus on at all.
That's where the politics comes into it all, I guess.
Correct, yes.
That's Dylan Gregg from the Curtin University node of the International Centre for Radio Astronomy Research. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. Early-stage trials in 25 patients have shown that a vaccine designed to stimulate a type of immune T cell to recognize and kill cancer cells is showing positive results. The findings, reported in the journal Nature Medicine, could help prolong long-term recurrence-free survival in some cancer patients. The vaccine is not personalised to people's individual tumours, but instead trains the immune system to attack a specific type of cell carrying a protein called KRAS, which is often mutated in people with specific cancers. The study found that after around 20 months, 68% of participants had developed strong T-cell responses specific to these mutant KRAS tumour proteins. The patients with the strongest T-cell responses also lived longer and stayed cancer-free for longer than those with weaker responses. A new study has shown that while being stuck at home during the COVID-19 pandemic, more parents were thinking about, shall we say, playing an away game compared to non-parents. A report in the journal PLOS One found that a survey of 1,000 American adults showed that parents were more likely than non-parents to cheat on their partners during the pandemic. In fact, the authors found that parents were both more likely to think about cheating as well as actually having an affair, with 20.7% of parents engaging in infidelity compared to just 13.9% of non-parents. They also found that males were more likely to cheat and think about cheating compared to females, although among the parents, both mothers and fathers showed similar patterns. The Australian Navy signed a contract to purchase 11 Japanese-designed upgraded Mogami-class FMM guided missile frigates. Developed by Mitsubishi Heavy Industries, the 4,880-ton warships will be equipped with 32 vertical launch cells capable of firing long-range Tomahawk cruise missiles. The new $10 billion fleet will replace the aging Anzac-class frigates and will work closely with Canberra's Aegis-class destroyers. The first 3 frigates will be built in Japan, with shipbuilding yards in Western Australia expected to produce the remainder. The first of these new so-called stealth frigates should be in the water by 2030. In 2021, Australia announced a deal to acquire at least 3 American Virginia-class nuclear submarines, with a further 5 SSN-AUKUS nuclear submarines to be built in South Australia under an agreement with the British Royal Navy. The SSN-AUKUS subs will use a combination of Australian, British and American technologies. Well, despite all the scientific advances in medicine, there are still millions of people who practice worthless traditional Chinese medicine pseudoscience to make up for their, shall we say, lack of manliness. The result is the slaughter or cruel captivity of thousands of innocent animals, including many rare and endangered species. Tim Mendham from Australian Skeptics says the science proves it simply doesn't work, but men with teeny-weeny attributes simply don't care.
The animals that they use and abuse, quite frankly, for this medicine things, for phony treatments, quite frankly, that don't work. Rhino horn, of course, being used as an aphrodisiac, curing impotency issues.
I thought that was only something that people with small worried about.
I haven't checked, I must admit.
Fair
but it
enough.
could be. Tigers, bears, the bile from bears, pangolins, of course, with the scales or whatever. Wild musk. It's a terrible situation that is actually wiping out animals. Seahorses are being sort of wiped out by this traditional Chinese medicine for cures that are totally, just because it's traditional doesn't mean it works. It just makes it sound good. It's unfortunate that prime effect of traditional Chinese medicine when it uses these animal products is that they just ruthlessly pay money for animals which are just torn out of their natural environments and killed for a very small bit of it if they're not farmed, like a lot of the bears are for farming the bile ducts and have a little tube stuck in there forevermore, and they're kept in awful conditions. It's a real problem, and it still exists. The rhino horn. The tigers are sort of have been banned, the tiger bones to be used in China, but there's still people there using it. And actually, a lot of them, overseas Chinese practitioners, not in China, are using tiger bones as well. And you think, is it animals being depleted from the natural environment? These are endangered species, if not wiped out entirely, for one small part of their body, and it's a real concern from a natural environment point of view. There definitely is a concern, and certainly also from a medical point of view, because they don't actually do anything. It's a false treatment with a major problem associated with it.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.